Hello, this is the fourth question. In this, we have to design a gray counter. So, in gray counter, in decimal, I'll be taking decimals. So, it goes from 0, 1, 3, 2, 6, 7, 5, 4, and back to 0. So, we'll be making this counter using three functions. In one of the function, I'll convert these gray codes to binary, and after converting it to binary, in the next function I'll convert that number to I'll increment that number by 1, and finally in the third function, that is the last function, I'll convert it back to gray. So let us see the code. So in this code you can see in this entity, clock is defined as the input and Q is the output. As I explained in the question, we have three functions: uh, gray to binary function, incrementer function, and binary to gray function. And I have declared a temporary signal. In this temporary signal, I'll use this temporary signal because our Q is declared as an output node. So I'll finally connect this temporary signal to Q itself. Okay. So you can see I made a process. I declared three variables in which are binary to gray, gray to binary, and an incremental. And finally, after obtaining different values, I update the value to the temporary variable, temporary signal in each positive rising edge of the clock. It is important to see that the signal temp is declared as 0, initialized at 0, and finally the temp is connected to Q. Now this is the test bench for this code. In this I have simply declared a component with the same entity name gray counter, and I made a signal declarations clock and Q, and I have converted clock to clock bar in each after each 10 nanosecond. Now let us compile and simulate it. I'll run the gray counter test bench. Now you can see our values which were initialized as 0 gets updated to 1, then 3, then 2 as the gray counter uh, is, and it updates at each positive clock edge. So I think my this design is working correct. Thank you.